Welcome to MENG 4313, section 031. We are covering pressure transducers, and we are group 8. I am Sergio Hernandez.
Steve Strahan.
Van Burnett.
Milot Seamus.
Samuel Morales.
Michael Geddes.
What is a pressure transducer? A pressure transducer converts an applied pressure into an electrical circuit. It produces an electrical output signal into voltage, current, and frequency proportional to the pressure. It is designed to produce an output that is linear with applied pressure and independent of the system variable. It is made up of two parts, an elastic material and an electrical part.
How does a pressure transducer work? A pressure transducer converts pressure into electrical output signal, such as voltage, current, and frequency. The sensor in the transducer allows the transducer to proportionally react to the applied force of the pressure. Majority of pressure transducers operate using electrical input and responsive to change in both pressure and temperature. The electrical devices in transducers. The most common configuration of the elastic material in the transducer is the diaphragm. 3 different types of electrical devices can be attached to the diaphragm to create an electrical signal. First being a resistive transducer, which uses a strain gauge. The strain gauge is bonded to the deformable material, and any change in the deformation causes the change in the electrical resistance of each strain gauge, which can be measured by a Wheatstone bridge. Second would be a capacitance transducer, which uses a capacitor and capacitance plates. Change in pressure is measured change in capacitance between 2 capacitance plates. One plate is bonded to the deformable side of the elastic material, or the diaphragm, while the other one is bonded to the unpressurized surface. Third being the inductive transducer, which contains a ferromagnetic core. The deformation of the elastic material is used to provide the linear movement of the ferromagnetic core. This linear movement will vary the induced AC current. The signal in each type of device usually has a linear relationship with the displacement of the diaphragm. Other types of transducers, including what's already been mentioned, the diaphragm, board-on tubes, bellows, and capsule.
Temperature is a major consideration in the performance of a pressure transducer. Pressure transducers are specified to have a compensated temperature range and an operating temperature range. If the transmitter housing temperature falls outside this range, the output signal may show an extreme drift, or the transmitter may stop operating altogether. Even relatively brief exposure to temperatures outside the specific range can lead to permanent damage. The median temperature directly impacts the overall performance and accuracy of the pressure sensor readings. It is important to remember that the temperature compensation circuit is mounted inside the body of the sensor. Therefore, to ensure proper compensation, the complete font assembly of the sensor must be heated or cooled. If the sensor is subjected to a heat shock, either via the pressure media or from the surrounding environment, large errors are possible that can exceed the specifications.
So now we're going to talk about pressure spikes. Some causes of overpressuring include unintentional heat applied to the system, faulty pressure regulators, or fluid hammering, which is basically a shock wave produced by the sudden stoppage or reduction of a fluid flow. Pressure transducers can withstand occasional pressures up to their proof pressure rating, eventually returning to their natural state. Pressure spikes can rupture pressure transducer diaphragms or casings and cause leakages. Pressures above proof but below burst pressure can result in permanent diaphragm deformation, making future readings inaccurate. To prevent overpressure and pressure spikes, we must understand the dynamics of their system and the limits of the transducer. Furthermore, we can prevent pressure spikes from safety factors. Generally, a pressure transducer is chosen to have twice the pressure measuring capability of what is needed in order to prevent the risk of overpressuring and pressure spiking. For example, if we have a required pressure rating of 100 psi for measurement, we'll need a sensor or pressure transducer, in this case, which can handle measurements of up to 200 psi. Another way is to have restrictor plugs, which serve as dampening elements to the sudden rise in pressure within a system.
Sources of error in pressure transducers. Mechanical design. Extreme temperature fluctuations. Extreme temperature fluctuations may change the transducer's output signal even though the pressure remains constant. Sensitivity errors. In some sensors, the sensitivity is defined as the input parameter change required to produce a standardized output change. This can cause error in measurement if the input is not within the sensitivity range of the transducer by loss of data. Nonlinearity. The linearity of a transducer is an expression of the extent to which the actual measured curve of a sensor departs from the ideal curve. This error shows up as an exaggerated output when compared to the actual value. Linearity is often subject to environmental factors, including temperature, vibration, acoustic noise level, and humidity. Hysteresis. A transducer should be capable of following the changes of an input parameter regardless of which direction the change is made. If an error exists, there may be a discrepancy in measurement for increases or decreases in input data. Offset errors. The offset error of a transducer is defined as the output that will exist when it should be zero, or alternatively, the difference between the actual output value and the specified output value under some particular set of conditions. If an offset error exists, the actual and output data will not match. Response time. Sensors do not change output state immediately when an input parameter change occurs. Rather, it will change to a new state over a period of time, called the response time. This might cause error by simply not reacting fast enough to record a data point.
Pressure transducers is used in various applications. First one is off-highway vehicles, for example, is load weighing system and load moment indicating. Next thing is natural gas equipment. As an example of this, compressor and dispensing equipment. The third example is semiconductor processing as a wafer manufacturing. Next thing is power plants, piping system pressure, and it can be also used as refrigeration, compressor, and loop oil pressure sensors and equipment. The next thing is can be used as robotics as a factory automated equipment, and also can be used as a test measurement, dynamometric, medical instrumentation, and wind tunnels. Barometric as well can be used as an altimeter certification weather station. Also it can be used in HVAC as a compressor, filter monitoring, and energy management. And transportation as a braking, compressor, lift, air conditioning. Medical devices as a blood pressure measurement.
Any questions? This was Group 8 covering pressure transducers.